so starting with multiplicity. Mainly with multiplicity, we just need to define it. Multiplicity, let's see. If I had a polynomial and I could factor it all the way out. I don't even care what the factors are. But let's say that this factor happens 3 times, this factor happens twice, and this factor happens 5 times. The number of times each factor occurs, that's the multiplicity. Now, the multiplicity of a 0 tells you what happens when it occurs. I can't spell today. So if your multiplicity is even, then whenever you go to graph, your graph is going to bounce off of the axis. If your multiplicity is odd, then you're going to go through the axis. Okay, does that make sense? And you guys have seen this before. Whenever you were graphing parabolas, if you ended up with something that looked like this, then you ended up with a parabola that looked like this. But if you had one that looked like this, then your parabola looks like this. Well, this has a multiplicity of 2, so this has an even multiplicity, so it bounces off. These both have a multiplicity of 1. So they had all odd multiplicity, so they went through the axis. So again, this isn't anything new. Wherever you graph a line, your line goes straight through because that 0 has a multiplicity of 1. Okay, so what we want to do is we want to put this all together, and we want to take that and graph it. So we start, first thing we do is we start with our end behavior. Okay, this is an odd positive. So that means on the left-hand side it's going to go down, and on the right-hand side it's going to go up. So that was from rules yesterday. So as x to the fifth, so since it's fifth, it's odd. The number in front of it is just 1, so it's positive, so our end behavior is down, up. So let's see. Let me start a graph down here in the corner. I'm just doing a sketch. It's nothing important, so it doesn't even matter what I do. So far, this is what I have for my graph. Okay, so next step is I need to find my zeros. So I take this and I set it equal to 0.
What's the end behavior?
End behavior is down, up. Okay, so you pretty much have to use whatever you can in order to get your answers. Well, to start off, I see that I can pull out an x. They all have an x in common. Okay, this inside here, this is something called quadratic form. Anytime this power is double this power, we can factor it like normal. So if this was a 5 and this was a 10, we can just factor it like we normally would. 3 and 6, factor it. So we have 2 and 4, so we just factor it like normal. So I'm looking for two numbers that multiply to 9 and add to -6. So -3 and -3. Now, the only difference between this and normal factoring is whatever your power was in the middle is what you have to use right here. So x squared minus 3, x squared minus 3. So now that I have it fully factored, I set each factor equal to 0 to find my answers. So great, I have x equals 0, x squared minus 3 equals 0, and x squared minus 3 equals 0. Okay, well, let's see. That's x squared equals 3. So x equals plus or minus square root of 3. Now, since I'm putting this on a graph, that's about 1.7, right? Okay, this one was the exact same thing. So this is also going to come out to be plus or minus square root of 3. So if I come over here and put those on my graph, I have one there. I have one at negative 1.7 and negative or positive 1.7. Okay, I'm going to write these out down here just to make a point. Okay. Multiplicity. What is the multiplicity of the 0? How many times did it occur? Once. How many times does the negative 1.7 or the positive 1.7 occur? Twice. How about the negative 1.7? Twice. Alright, so whenever I go to graph, my end behavior down here is down, so I need to come from the bottom. Since this one occurs twice, I need to bounce off of it, go through the 0, bounce off of that one. Remember, I should be making curves, not corners. And then go up. Now, a good way to check and make sure that you did the correct things with your multiplicity is whenever I start down here, my end behavior up here should be up. So I should be ending in the correct place. Do not force your end behavior. I see all the time on papers, you know, someone messes up their end behavior. So they're doing their graph and they got this one correct. They went through the 0, but then they went through this one. And, oh, my end behavior is wrong. Oh, sorry. My end behavior is wrong. I need to be up. So they just go like this. Well, great. You have the correct end behavior, but now you added another 0. So you still made your problem wrong. So if you're not getting correct end behavior, that means you did something wrong someplace else. So your end behavior is a good way of checking yourself. Alright, I was only going to do one. This takes a little bit longer, so I was only going to do one example of this. Any questions about that? We good with that? Okay. Now, I was going to leave that. I want to use that for the next part, but you guys have that in your notes so you can see it. Zeros and curves. Whenever we did that last graph was an x to the 5th, right? How many zeros did it have? Okay, it had 3 zeros, but it actually really had how many zeros whenever you count the multiplicity? 5 zeros. And how many curves did it have? Just a second. Okay. Now, these are up to numbers. It should always have 5 zeros. However, let me generalize this. It should always have n zeros. Wherever you count multiplicities. However, it can have up to n x-intercepts. Does not have to have n x-intercepts. Whenever you start counting multiplicity, if you look back at that graph, it only had 3 x-intercepts, right? But can that graph have 6 x-intercepts? No. It could have 0 x-intercepts, right? If all of it... No, actually it can't have 0 x-intercepts. It has to have at least 1 x-intercept. And I'll explain that here in just a second. It has to have at least 1. An even-powered function can have 0. An odd-powered function has to have at least 1 because... Let me explain why it has to have at least 1. An odd-powered function has to have end behavior that goes in opposite directions, right? Let me make sure. Yeah. Wait. No, wrong person. Okay. Odd powers have to have opposite direction of end behavior, correct? So if I start a graph going down and I have to end it up, it has to cross the x-axis at least once. Even powers, though, since they go in the same direction, I can start down and end down without ever crossing that line. But an odd power has to have at least 1. Now your number of curves can be up to 1 less curve. You always, well, I don't want to say that. You don't always have to have 1 curve because a line doesn't have a curve. But 1 less curve for a line would be 0. So a line is kind of a special case. But all the rest of them have, yeah, it gets iffy. Because if I take an x cubed graph, technically that's a curve, but that's not a curve in the sense of going like that. And where we're talking about the curve, we're talking about this. Yeah. So when we're talking about the curve, we're talking about change in direction. So these are kind of your rules for your zeros and your curves. So zeros, you have to have n zeros if your power is x to the n. That does not mean they all have to be real. They can be imaginary. Okay. So let's do this. How much time do I have? We get out at 11:09. Oh, I got plenty of time. Okay. Yeah. Okay, go ahead. Yeah, I know youth court had to leave early. Okay. Finding zeros of polynomials. Okay, all this really means you're doing these are the zeros, so we're going to turn the zeros into factors. And then we multiply. So it's nothing special. However, we're going to make it a little bit bigger than what we've done before. We have 2 zeros, but it tells me my degree is 3. Is this going to give me a degree of 3? No, that gives me a degree of 2. So one of those has a multiplicity of 2. You get to choose because they don't tell you. So you either get to put a squared on the 3 or the 4. So on these problems, a lot of you can have different answers. It's fine. So I'm going to put the squared on this one. But that's what it comes down to. You just need to make sure you have a degree of 3. They only give you 2 zeros, so you pick one. Then you need to multiply it out. Let's see, x cubed, x squared. Yeah. Mm-hmm. Yep. Yep. So whatever the degree is, you should end up, that should be your largest power. Oh, I missed one there. Plus 9x. So there's my polynomial. Again, there's multiple possibilities. On this one, there's only 2 possibilities because you either squared the x plus 3 or you square the x minus 4. All right, now there's a couple other weird things that happen, so I have a couple more examples, but we're pretty much done. You good on that one? Okay. These, anytime you have square roots, and imaginaries, when we get to the imaginaries, always have to occur in something called conjugate pairs. Conjugate pairs look like this. So that's what conjugate pairs look like. You change the sign in front of the square root. But they always have to happen in conjugate pairs. So that means the degree is 4 on this. This one is already dictated what it has to be. There's only one option of what this one can be. The only thing that can have a multiplicity is the 1. Because if I give this one a power of 2, then this one also has to have a power of 2. Okay, so if I go through this one, let me show you another trick here. You always want to multiply your square roots together. Never multiply them with something else. First of all, they'll always end up being difference of squares. So they will always cancel out your square roots. Let me do this first one the long way, just to show you that. Yeah. What one? This one? It was part of the original problem. Yeah. Dang it. Because I have to have something with a multiplicity of 2 because my degree is 4. So the only thing up here that can have a multiplicity of 2 is the 1, because since these have to happen in a pair, I can't give this a multiplicity of 2 without giving that a multiplicity of 2. So that would increase my degree too far.
I'm intrigued where you said that. How do you get the multiplicity of 4?
You were given that. You were given your degree of 4. So since my degree is 4, I have to have 4 x's. So my only choice is that x minus 1 has to be a square. Yes, they have to have a multiplicity of 1, because if I were to do this and do that, the only way to do that is if this one was also squared. Because they have to occur together. But then if I did that, then this gives me a degree of 5, because I have 5 x's. I have 2 x's here, 2 x's here, and 1 x there, which is not what my problem said. Yeah. A 1. I drew my parenthesis before I wrote +1. So see, now I have my degree of 4. So the main point I want to get at with that one is your square roots have to happen in conjugate pairs. And wherever you multiply them together, make sure you multiply them together first. Or don't multiply them together with anything else. Put your square roots together, because they'll make your square roots cancel out. What do you mean? Depends on what you need. I mean, if I ask you for, if I gave you something like this, and I ask for a degree of 5, you could make it like this. That would give me a degree of 5, right? Okay, now, occasionally they didn't do it in today's homework, and some of the homework later on they're going to do it. But occasionally they're going to do stuff like this. That has a degree of 3, but there's only one possible answer for this one. What is your... They left one of your zeros out. What's your missing 0? Yeah, 1 minus radical 3. Since they have to occur in conjugate pairs, since you have a 1 plus radical 3, you have to have a 1 minus radical 3. So they're going to do that to mess with you occasionally. Like I said, it didn't show up in today's homework, but I know in some of the homeworks later on it does. Now, also, I'm not going to spend the time to multiply this one out because notes have already taken a lot longer than I expected them to. But let me show you how to write this one out, because this causes confusion sometimes whenever you have more than one thing here. All right, whenever we take a 0 and we put it in here, we subtract it, right? So like this negative 2 would be minus negative 2, so it would become plus 2. So you do the same thing with these. So I have x minus this. So if I subtract that, that would become minus 1 minus square root of 3. So if I subtract this, that would be minus 1 plus square root of 3. So just remember, wherever you put them in your factors, you have to subtract them. So just subtract them and do your math how you need to. All right, good? Okay, and again, wherever you go to multiply it out, just FOIL this out. It'll work out nicely. You'll end up with something that looks like x squared plus or minus just a single number. Just trust me, it'll work out nicely. All right. And then it's not as bad as it looks. Some of them were just simply, what's the end behavior? You could write the words, you can draw the arrows. Again, as long as you can identify what the end behavior is, it's fine.